AP Calculus AB, we're in Notes 2.5. This is part 4 of 5. For this prompt, we are told what a derivative equation is, and it's in factored form. And we have several questions that we're supposed to answer as a result of that. So we see f prime here, and it's in factored form. Question 16. On what intervals is f of x increasing, decreasing? Justify your answers. Well, if you're given the derivative, even if you're given the original function, and you want to know where it's increasing or decreasing, we need a first derivative sign diagram. In order to know what goes on the diagram, we need to figure out the zeros of f prime. So f prime of x is going to equal 0 whenever x equals -3, 0, and 2. Because if we set each factor equal to 0 and solved each of those, we would get these answers. That is the factor theorem in play. So if we put a 0 in here, we would get 0. If we put 2 in here, we'd get a 0. If we put a -3 in here, we'd put a 0. I recommend that you write these in ascending order. Once you know when f prime is going to equal 0, you're then going to make a number line. On this number line, you're going to include each of the zeros of f prime. You would also include when f prime is undefined, but we haven't got to that point yet. So we got it -3, 0, and +2. I'm just going to break this apart so we don't run our stuff together. Now we need to take this version. Let me get myself a little bit more space here. We need to take this version of f prime, this version meaning the factored version, and we are going to plug test points in on each of these intervals. For example, let's say that we pick a test number of x equals -4, or here we choose x is -1, or x is +1, or x is 100. Pick a test number from each interval, and we plug it in to see if we're going to get a positive or negative result for f prime. If I put a -4 in for this, it's going to be negative. If I put a -4 in here, 2 minus a -4 is like 2 plus 4. If I put a negative in here, a -4 plus 3 is negative. If I multiply two negatives and a positive together, that's going to end up making this positive. So I know to the left of -3, it's going to be positive. If I put -1 in, I'm going to have a negative. 2 minus a -1, it's going to be positive. -1 plus 3 is going to be positive. This is going to be negative, this interval. If I put a 1 into this, 1, 2 minus 1 is 1, 1 plus 3 is 1. It's going to be all positives. So this interval, we're going to have positive values for f prime. And this last one, the reason I put 100 in, sometimes putting in big numbers is actually better, because 100's positive, 2 minus 100's negative, and then 100 plus 3 is positive. So I have a positive and a negative and a positive. Multiply those, I'm going to get a negative. Excuse me. That was wetter and more wild than you could possibly imagine. So that's negative. So to answer the question, at what intervals is f of x increasing? Justify your answer. When is it decreasing? Justify your answer. Well, here's what I know. I know that f prime of x is greater than 0 on the interval from -∞ to -3 in union with 0 to 2. This interval is positive, and this interval is positive. conclusion that I can form from this is that f of x is increasing. I can say on these intervals, or I can repeat these intervals. I'm just going to say on these intervals. Similarly, I could say that f prime of x is less than 0 on the interval from -3 to 0 and from 2 to infinity. And because f prime is less than 0, I could conclude that the original function f is decreasing on these intervals. So the whole point of this sign diagram, right through here, which you would need this on the AP Calculus test to show that work. When I say show that work, you would have to show a number line. You have to have these numbers on here, which, tell you what, let's circle those numbers. You wouldn't have to circle them. And you'd have to show positive, negative, positive, and negative. You wouldn't have to show this. You wouldn't have to show the numbers that you plugged in. Anyhow, this is necessary to tell us when the derivative is positive or negative, which we could then conclude whenever the derivative is positive, the original function is increasing. Whenever the derivative is negative, the original function is decreasing. 17. At what values of x does the graph f of x reach a relative minimum? Justify your answer. Well, we're using this sign diagram for f prime again here. We don't need to draw it again. But in order for this to have a relative minimum, f prime would have to change from negative to positive. And that happens, changes from negative to positive right here at 0. So f prime of x changes from negative to positive at x equals 0. Therefore, f of x has a relative minimum at x equals 0. Question 17, I'm just going to copy this down just so I can see it. Actually, let's just copy down the part that we have to have. This is the part that we would have to have. At what values of x does the graph f of x reach a relative maximum? Well, that happens when f prime, you know what, and I don't know if I labeled that well. I didn't label it at all. Back up here, we should really label this as f prime. So we know it's a first derivative sign diagram. My apologies for that. F prime of x changes from positive to negative at x equals -3 and x equals 2. Positive to negative here, positive to negative here. Therefore, the original function f of x has relative maximums at x equals -3 and x equals +2. Or you could say at these x values. Either way. All right, let's get rid of this. We got 2 more to answer related to this. 19. If f of 4 equals -1, what is the equation of the tangent line drawn to the graph of f of x at x equals 4? We are all about the equation of the tangent line, aren't we? Our point of tangency, we're told, is 4, -1. Slope of tangency, well, we don't know that. However, we are given this graph, this equation for f prime. If we plug 4 into it, just taking this derivative right here and we're putting 4 into it, we're going to get 4 times -2 times 7. 4 times -2 is -8. -8 times 7 is -56. So our tangent line is going to be y plus 1 equals -56 times the difference of x and 4. On the AP Calculus test, if you this is a non-calculator part and you get here and you freak out and you think I don't know how to multiply, or you get here and you don't want to multiply it out, you can put this whole thing as the slope right here. It's better if you can simplify it, but if you panic or run out of time, you don't have to. So question 19, what's the equation of the tangent line? We got it. 20, approximate the value of 4.1. So let's do that. So if we're supposed to approximate it, we're going to have to use a tangent line approximation. So y plus 1 equals -56 times the difference of 4.1 and 4. Going to subtract 1 from both sides. 4.1 minus 4 is 0.1. -56 times 0.1 is -5.6. And whenever you're multiplying 1/10 or 0.1 times something, it just moves the decimal point over one place to the left. So this is going to be -6.6. So f of 4.1 is approximately -6.6. Is f of x concave down? I'm sorry, it tells us f of x is concave down at x equals 4. Concave down means like this, which means our tangent line has to be above it. Is this an over or under approximation? So we would say that f of 4.1, which is approximately -6.6, is an over approximation. Tell you what, that's not wrong, but let me write this in the same way that I wrote the last time. The way I wrote it last time is that we wrote f of x is concave down at x equals 4. Our conclusion, therefore, the tangent line is above f of x. Therefore, f of 4.1, which is approximately -6.6, is an over approximation. Cool. All right, that finishes this part, which was us given the derivative in algebraic in an equation form, and then answering various questions on it. And then we will do the last part here of the notes next, part 5 of 5.